So hello, good evening. Okay, so today we want to look at this question. We are asked to resolve this into partial fraction. So what we are going to do here first is that we need to confirm if it is a proper fraction. So to be able to confirm that, we need to guess the highest power of x here. If this one is expanded, is 2, and the highest power of x here is 2. 2 times 2 is 4. So the highest power of x here is 4, and the highest power of x here is 3. So it shows that when the highest power of x at the numerator is less than that of the denominator, it's confirmed that it's a proper fraction. Otherwise, we need to divide. Okay, so now it's a proper fraction. So because of that, so we can proceed. Okay, so what do? The next thing we want to look at here is that this is a repeated root. It's a repeated root because this factor x plus 1 is squared, right? So it's going to be represented like this: a all over x plus 1 plus b all over x plus 1 square. That's for the repeated factor, repeated one. Then for this one, it's a quadratic expression. Because it's a quadratic expression, then what will be at the numerator is going to be linear. So this is going to be cx plus d all over x squared plus 1. So this is how we are going to write the partial fraction. So we will now look for A, B, C, and D. So how do we now look for A, B, C, and D? So the first thing we'll do is use this to multiply every term here. That is just like we are cross multiplying while this one is inside the brackets. We use the denominator here to multiply all the terms there. So when we do that, this is going to be 2x cubed plus 2x squared plus 2 to be equivalent to, now when this one cuts this, what will be left? A will be left with what? X plus 1 and what? X squared plus 1. And when this cuts this, this one and this one will go, only this one will be left. So B will be x squared plus 1. Then for this one, cx plus d. So x squared plus 1 will cut this, only this will be left. So that will be x plus 1 squared. Right? So this is the expansion of this equation. So we will now need to expand this as well. So now let's go about the expansion. X cubed plus 2x squared plus 2 equals a into x times x squared. This is x cubed. Then x times 1. That will be x. 1 times x squared. That was x squared. 1 times 1, 1. Then for the b, that will be b into x squared plus 1. Then plus this one, we need to expand this first. Cx plus d. Those will be x squared plus 2x plus 1. Right? Okay. Now the next thing we want to do here is now to expand this further. We need to expand that one. So this is going to be cx times x squared. So that will be 2x cubed plus 2x squared plus 2. Then this is going to be a x cubed plus x squared plus 1. And this is going to be b into x squared plus 1. Then plus, when you now use cx to multiply everything, then you also use d to multiply everything here. So this is going to be cx cubed, right? Cx times 2. that will be 2c x squared. Then cx times 1, that will be cx. Then d times x squared, that will be dx squared. Then d times 2x, that will be 2dx. And d times 1, that will be d. Right? So that's the expression there. So we will now do comparison. We'll compare the left hand side and the right hand side, their coefficients. For the one whose degree is raised to power 3, anyone with degree raised to power 3, will compare them. So the coefficient to bring them out, that will be 2 on this left hand side for a s cubed. So it is a that is left here, right? Then for b, no s cubed there. C has s cubed, so that will be plus c, right? Any other one with cube? No. So this is one of the equations that we're going to get. Then so okay, so from here we'll now compare x squared, the ones with x squared. Now to compare that, this 2 is here on the left hand side. Then on the right hand side, anyone with x squared, a times x squared, that will be a. Then b times x squared, that will be b. Then c x squared, 2c, we have 2c here, right? Then d times x squared plus d. So anyone with x squared, that's what we're going to do. So this is going to be equation 2. Then the one with ordinary x, we compare it as well. So what are those? So there is no x here, so it means the coefficient here is 0. So the one with x here, a times x, that will be a. The one with x, no x here. The one with x here is this, c plus c. Then 2dx plus 2d, right? So we have that as well, right? So that is equation 3, right? That's equation 3. So the next thing we want to do now is we'll compare the constant term. So which ones are the constant term there? So let's look at the constant term. The constant term, that's 2 on this side. So any constant term here, a times 1, that's a. Any constant term here, b plus b. Any constant term here. So do we have any constant term here? That's d plus d, right? As this d. So that shows that's a constant term. So this is the equation 4. So here we have 4 equations and 4 variables, a, b, c, and d. So we want to solve these equations simultaneously. So what we'll do is we say from 1, we say let it be equals to 2 minus a. From 1, c is what? 2 minus a. We now substitute this value in which of these equations? So we want to see where we have, so we can substitute that in equation 3, right? So substitute in equation 3. So substitute 2 minus a for c in equation 3. So in this equation now, this is 0 equals to a plus c is now 2 minus a plus 2d, right? So from here now, what are we having here? So if we put this 2 minus a, c is 2 minus a, so 2a and a will cancel out. We now have this to be, we can get our d from here.
3,
so what is d?
2, 1.
So if these two come to the other side,
Pause.
so d is going to be minus 2 all over 2, and that will be minus 1. So d is minus 1 from there, right? So after getting d, also if we look clearly from here, from equation 2, we substitute for C, which is what? 2 minus A. So it's going to be 2 is equals to A plus B plus 2. This is what? 2 minus A is C, right? Then plus D. Okay? So that will be 2 is equals to A plus B, right? Plus 4 minus 2A plus D, right? Okay? So from here now, what is A plus B? That will be 2 into, meanwhile, D is already obtained as minus 1. That will be B minus, what is A minus 2A? A minus 2A is what? Minus A. Then plus 4. So let that 4, let it come to the other side. So that will be minus 4 plus 2. Then D is obtained as minus 1 here. So by the time that minus 1 comes to the other side, it becomes plus 1, right? Are we good to go from there? So here now, we know that 1 minus 4 is minus 3, and minus 3 plus 2 is what? Minus 1. So B minus A is equals to minus 1. So minus 1 is equals to B minus A from here, right? Okay, and since we know that to be, so how do we now get, we know that this is B minus A. Then the next thing we want to do now is to substitute in this equation, in this equation 4. So we know that if we multiply through by minus, it's going to be A minus B is equal to 1, right? Okay, and A from here is equals to B plus 1, right? A is equals to B plus 1. So A is equals to B plus 1. Now, if we substitute that in this equation, what's going to happen? Substitute this. This is equation 4, 5, let's say equation 6. So substitute B plus 1, right? B plus 1 for A in equation 4. So what's going to happen there? So that will be 2 is equals to A is B plus 1 plus B plus D, and D is minus 1, right? Put it there. So we only have B here now. So plus 1 minus 1 is gone. So this is 2B is equals to 2. And from here, we know B is equals to 1. That is 2 over 2. That's 1. So we have been able to get B. So from here, A can be gotten. A is equals to what? B plus 1. And B is 1. So it's going to be 1 plus 1. That will be 2.
A plus B. 2B.
So that's how we obtain A,
No,
B,
that's
C,
2B.
So what is C? We know already C from our initial C is equals to 2 minus A. From 5. This is our 5. From 5, C is equals to 2 minus A. And that will be 2 minus, what is A? A is 2. So C is equal to 0. So we have been able to obtain A. It will be 2. B is equal to what? 1. C is equal to 0. And D is what? Minus 1. So now that we have obtained all the letters, we can now put them in this expression. So what is A? A is equal to 2. So we'll put A here, which is 2. A is equals to 2. A is equals to 2. What is B? So B is equals to 1, right? B is equals to 1. Then what is C? C is equal to 0. So it means there is no expression for C. And D is minus 1, right? D is minus 1. So this is going to be minus and the 1 here. So this is the final expression of the partial fraction. Thank you.